Welcome to Chapter 5. As you can see from the slide, we're going to deal with something called discrete probability distributions. If you remember, discrete means there are gaps between the data. So we're going to look at what is a probability distribution, which really ties in with what we just dealt with, which was frequency distribution that gives us a probability distribution. It's the area underneath the curve. That's really what it comes down to. How to calculate the expected value, which is like X bar in our previous examples, and the variance of a probability distribution. We're going to do binomial, we're going to do Poisson, and we'll talk about what they are and how to use those two distributions in business settings. Discrete, all right, counting numbers. Continuous, it is just that. So another way to describe it is discrete's like digital. It's blocks. Analog is like continuous. So if you want to think of them in the sense that discrete are these blocks with gaps between them, and continuous is exactly that. So once again, here's a nice graphic on the two. You can see the discrete has the gaps and the continuous does not. It is. So one of the ways to look at it is it possible, and in a very simplified way, is it possible for the numbers to have, this is not 100% accurate, but it's pretty close. Is there a possibility there's a decimal place? When you count the number of students in a class, you can't get 3.2 students. It's either 3 or it's 4, so that's discrete. But if you were to take an average of the number of students who attend a class, you take the attendance every day, and then you took the average of that, is it possible to have an average of 27.1? Yes, it is. But on any individual day, you can't have 27.1 students. So maybe that helps to understand a little bit about the differences between the two. As you can see, we're dealing with Chapter 5, so we're going to deal with the discrete, and then in Chapter 6, we'll deal with the continuous variables. Again, here's an example of dice, or die if it's 1. Anyways, let X be the number of times 4 occurs. All right, and toss a coin to see the number of times you get heads. So in this particular case, if you roll a dice twice, you can get 0 times a 4 occurs, 1 time it occurs, or 2 times it occurs. So that is discrete. It's not to get 1 and 0.5. If you toss a coin, you either get heads or tails. If you toss a coin 5 times, you either get 0, 1, 2, 3, 4, 5. So counting numbers, you know, like we learned how to do on our fingers way back when. Now, when you have a probability distribution, so this, in this particular case, you have a 35% chance there'll be 0 occurrences of interruptions in the computer network. There would be a 25% chance there'll be 1 interruption per day, and you can read the rest of the table. So this has a frequency distribution, but the data is discrete. There's either an interruption or there's not. So what you can do in this particular case to find the expected value, which is mu, is you take the number of interruptions and you multiply by the probability. And you in Excel, you would use a function called sum product. You take one column, multiply it by another column, and then total those values together. So the expected value, the average, is 1.4. So simply multiply the number of interruptions by the probability of the interruptions, and then total it up. So with a binomial probability distribution, it has a fixed number of observations. You can see 15 coin tosses, 10 light bulbs, or in the case of a multiple choice test, you would have, say, 20 questions to answer, or 80, or whatever the case may be. And you either have you only have two possible answers, success or failure. It's head or tail, it's a defect or not a defect. But also, you either get the question right on the multiple choice or wrong. That's why some people love multiple choice and some people don't, because there's not part marks. So some people don't really like that. But other people say, oh, well, what are the chances of me getting 100%? I either get it 100% or zero. You have the same weight. So what that means is this. If you have a multiple choice test and there's A through D, so there's 4 possible answers, but there's only 2 possible outcomes, you're either right or you're wrong. So in the case of A through D, if you had to guess, you have a 25% chance of being right, even if you have no clue. If it's in a language you don't understand or in a topic you don't understand, there's still a 25% chance that you will get the correct answer. So probability of success is 25%. The probability of failure is 75%. So you know that you can't go into a test without having more than just a guess, because your chances of passing are slim. Now, what if the questions are A through E? If there's 5 possible answers, it changes the probability. So there's still 1 correct answer. In this case, there's 4 wrong answers. So the probability of success is 20%, 1 out of 5, and the probability of failure is 4 out of 5, which is 80%. And in the final point, it means the values are independent. So sometimes students, I find it interesting that some students will like to overanalyze. Well, I've answered A 3 times in a row. The 4th one can't be A also. You look for patterns that aren't there. Every time they're separate or they're independent from each other. What the answer was for question 3 does not affect the answer for question 4, whether it's an A, B, C, or D. So I do remember years ago when I first used a test bank, it said, do you want to scramble the answers? I said no. So I looked at the answer key they printed out, and I had 20 questions. They were all A. I thought, ooh, would any student actually, quote, have the nerve to answer A as the answer for every single question? I'm not sure too many students would. And don't worry, I'm not going to do that to you. But one day, I'm going to do that to a particular class. All the answers are going to be A or whatever. And by the way, I know the common misconception is if you don't know the answer, pick C. That is actually not correct. You should pick the longest answer. Although I do work for book publishers and they realize that people are becoming aware of that if you have no idea what the answer is, pick the longest one. But I actually am doing work for publishers and they tell me to make sure that that is not the case. In fact, they built it into their software now that you can't have the correct answer is more than, say, 20% longer than any one of the other answers. Just as a little aside for you. All right. So manufacturing labels, they're either defective or not defective, or they're good or bad. They either get the contract or not. Will you buy? Will you not buy? You either accept the offer or reject the offer. So you look for different counting techniques. You can see again with a coin, there's 3 possibilities of how you get 2 heads. You either get head, head, tail, head, tail, head, tail, head, head. So there's 3 ways to get 2 times it shows up heads. And of course, if it showed up for all 3, that would be wrong. If it only showed up no times or 1 time, that would also be wrong. So there's 3 times. And so here's the formula. The exclamation mark, in case you may have forgotten, has to do with factorials. Yay. Then you have the pi symbol, and you have this nasty little formula. And fortunately, binomial probabilities are built into Excel. So once again, one of the beauties of using Excel is it's way faster. When I presented it over the last 3 years since I've switched to using Excel or spreadsheets, the students' marks have gone up. And the students are telling me that they understand it better because you're not going to go and do this in industry. Sit there with this formula. Like, that is so out of date, it's not even funny. So 3 years ago, I started using it at the request of the chair. I will never go back to using the formulas. And you're way faster. And you're more accurate. It's even more accurate than the formulas give you because there's more decimal places. It's built into Excel. And we'll go through some of the examples where we will use binomial. It's quite simplistic. You need to, though, understand how many observations you're looking for. In this case, 1. How many trials there are. How many times you're going to flip the coin is 5. And then the probability of success is 10%, which is 0.1. And so you're going to need to enter that into Excel. So here's again just another calculation. Probability there will be 1 late invoice out of 4, and there's a 10% chance that the invoice will be late. And this means you get exactly 1. There's a 29.16% chance that you get exactly 1 late invoice in 4. And you use that for measuring your quality or success. And here it is in Excel. We're going to do this. So in this particular case, you have a sample size of 4. Probability of the event is 10%, 0.1. And one of the things you may want to do for tests and assignments is have these pre-done, so it'll make your life a whole lot easier. You can see that they put in the very nice job of putting in the formulas for you. And what this does is you see that A14 is in this particular case, 0, which is, what's the probability of having 0? Then B4, and you might notice, depending on how experienced you are with Excel, the dollar signs. What that means is that's an absolute reference. So when you copy and paste it, it's still going to refer to B4. So you have absolute column B, absolute row 4. And then the same thing for B5. So if you want to copy and paste it or drag it down, then you need to make sure those are in absolute terms. And then false means that it's just there for it only is for 0. If you put true, it starts at 0 and then goes to whatever number. So in this particular case, for 0, it doesn't matter if you put true or false. It will give you 0. But if you, in the next one, where there's a 29.16% chance of 1 occurrence out of 4, if you put true, what it would do was it would be like the ogive, where it would be cumulative. So they had the 65 and the 29, and you want to wind up with about 94, 95%, whatever the two of them are together. So true will give you from 0, the starting point, to that point. So if you were to go from 0 to 2, what's the probability of getting none / 0, or 1, or 2? So you want 0, 1, and 2, and rather than adding it up, you would put true under row 16 instead of false. So there's a 4.86% chance there will be 2 observations out of 4. But if you want from 0 to 2, if you put true instead of false at the end of the binom.dist function in Excel, it will add up 0 and 1 and 2 for you. It is also good because then if you wanted something above 2, you could go 1 minus that number, or in this case, you can simply add 3 and 4 together. So it gives you lots of flexibility. You can see that the mean is simply B4, which is the sample size, times B5, which is the probability. So a 0.4% is the average or mean. The variance, you simply take the square root of the mean, or sorry, you take B8, which is the mean, and multiply it by 1 minus the probability of the probability of success. So it's really the probability of success times the probability of failure. So it's 0.4 times 0.9. I misspoke on that, sorry. What it is the probability of failure times the mean. Sorry, I misspoke. And then you simply take the square root of that. So for binomial, you take the square root of the variance, as we learned earlier, and you wind up with 0.6. So sorry about the variance. So just to say it one more time, you take the mean, which is B8, and you multiply by 1 minus B5. B5 is the probability of success. So 1 minus the probability of success will give you the probability of failure. I apologize for misspeaking earlier. So here's the summary of it. You will need, Excel does not calculate the mean for you. It just gives you the probability of 0, 1, 2, 3, whatever the case may be. And then you're going to have to calculate the variance and standard deviation. And again, you can pre-do these. Your tests are going to be online, as you're well aware. So there's no reason why you can't have a little spreadsheet done up with, the examples. And in fact, as a reminder, your assignments and your quizzes are going to be based on your study plans. So if you do a problem in the study plan and set up a spreadsheet to calculate the correct answer, you can use it during the test. So the study plan questions are going to be the same as your assignment questions. They're going to be the same as your quiz questions, and you can have them ready. The thing that will change will be the numbers will be different. Every single student gets a different set of numbers. All right, so again, here's some calculations. I'm not going to go through that too much. I'll let you browse it at your leisure. Poisson. Poisson is a continuous distribution, or has aspects of that. So it also is good at measuring things like number of scratches in a car's paint, mosquito bites, number of computer crashes in a day. So you can, number of hurricanes, number of snowstorms. It's identified by the Greek symbol lambda. And you can see that, I'll let you read the slide yourself, but you're interested in counting the number of times a particular event occurs in a given period of time. One of the biggest things with Poisson, it needs to have a definition. So how many errors are made per day? How many errors are made per hour? How many errors are made per page if it was typing? How many errors or defects do you have, or in so many kilometers of railroad track, things along this line. So you need some sort of context with that. So again, the mean is simply lambda and mu, which is left. Mu is the little u. Lambda is the kind of upside down y. The variance is the same as the mean, and the standard deviation is the square root of the mean. So that's nice, simple, straightforward. So if the mean is 16, the variance is 16. The standard deviation is 4. And as you can see, we have the same kind of thing as we did with binomial. In this particular case, the mean has an expected value of 3. So that's the average. So you have to be careful. When you read the question, if it says there are three errors per page, how many errors are there on 5 pages? The mean is not 3. The mean is 15 because you have 5 pages and 3 errors. So if you have 3 errors per page and you have 10 pages, the mean is 30. So you have to be careful with that. You have to quite often. So if I say on average there on a railway line, there is 2 defects per 100 kilometers of track. How many defects are there in 600 kilometers of track? Well, 2 in 100, and then of course 600, it'd be 12 would be the average. And then you find out the probability of no errors, 1 error, 2 errors, 3. But you have to change the mean very often, depending on what the original information is. So in this particular case, the mean number of customers who arrive is 3 per hour, right, from noon to 1. I teach this in my supply chain classes when I teach them about waiting lines. Waiting lines are considered to be based on a Poisson distribution. So if you have 3 arrive in an hour and you had an 8-hour day, you'd have to change your mean to 24. Now, Poisson, as you can see, is the same as binomial, except it says Poisson, obviously. And once again, the same context, except simpler. A8 is 0 in this case. And E4, which is an absolute value, is the mean. And false will only give you the results for 0 occurrences. So if you have 3 customers arrive in an hour, on average, what is the probability nobody will arrive? There'll be nobody. It'll be empty. No waiting line. The probability that nobody will arrive in an hour is 0.0495, and that's 98. So basically 5%. What is the probability 1 customer and only 1 customer will arrive in an hour? 0.1494. What is the probability that 2 customers, but only 2, exactly 2, 0.224, and the same for 3. Again, if you change the false to true, it will total it up. So if I wanted to know what's the probability there will be 3 or fewer customers, and you can do it the other way if you want. You can add up 0, 1, 2, and 3. Or you can simply change what would be in row 11 and you change the false to be true. So it's very similar to binomial. And a lot of students have found this, hopefully you find it very straightforward. It doesn't show you about the true, but we'll go through some of those when we go through the examples from the chapter. And this is what a Poisson distribution looks like. It is technically infinite. It has no upper limit, although the numbers get incredibly small. So here's what a Poisson distribution looks like with an average of 0.5 or 3. So the first one on the left kind of looks like a Pareto chart. And so but they have this flow. They kind of go up and then down, but the tail never touches the right-hand side. It's infinite if I were to draw this on the board. So we'll give you a chance to look at the summary. We looked at probability distributions, the expected values, the variances, the standard deviations. We looked at binomial and Poisson, and then we use some of it to solve business problems. We'll especially do that when we do the questions out of the book.